video on similar or proportional triangles, which are the same as similar triangles. And so this first one says complete the similarity statement. And so we're looking at these two triangles and they are similar. They are actually similar by what's called the AA. That's the angle theorem of similarity. We can look at this angle right here with the two arcs is congruent to this angle L with two arcs. So angle L and angle Q are congruent. We can write angle L is congruent to angle Q. We can also write that angle R and angle M. So angle R is congruent to angle M. And so because they have two pairs of congruent angles, they are congruent. And so you want to, when you're writing your similarity statement, your vertices that have the same congruence have to match up. And so they started this one triangle with L. Notice that we'll call that one in green here. That L has to correspond to Q. And so your next triangle you list here has to be triangle Q. And then because it went from L to M, from L to M, then we've got to go from Q to R. And then the only one left then is S, but you can say that those are congruent. Let's say, the N would be congruent to S, and we can see that plays out here as well. Now this next, the approaching proficient question, this is determine if the triangles are similar. If they are, state by what theorem and finish the similarity statement. So if we look at this one here, let's take a quick look at other theorems. And so there's a number of different theorems for proving similarity. I'm not going to go through them all. I do recommend that you study them and go through them and practice them in your homework. But I will go through the one that applies here, which would be side angle side similarity theorem. It says if the angle of one triangle is congruent to an angle of the second triangle, and the lengths of the sides, including these angles, are proportional, then the triangles are similar. And they've given an example here, but I'm going to go through the one on the other side here. So I know, like if I separate this out, and I say, on the one hand, I've got triangle PRQ, and then I've got the smaller triangle, which is PFE. So I know that this angle is the same. Angle P obviously is the same for both of those little the triangles. And so then the corresponding sides. This one is 10 and this one is 10. On the larger side, that 45 is the length of the full side. But if you take 35 and 10, since 35 plus 10 is also 45, this would be 45. And so you could say 10 is to 45 as 10 is to 45. So that's the proportionality of their sides. Say this side compared to this side, and this side 10 compared to this side, which is 45. And so that proportion is obviously the same on both sides. And so we would say, yes, these are similar, and they are similar by theorem side angle side. And if triangle PQR P, Q, R in that same order is then is similar to triangle P, E, F. All right, this next one. Look at this one. It says, if these are going to be similar, they would also be similar by side angle side, because there's the two sides and the angle is in between them. So side, angle, side, side, angle, side. Now we just have to see, obviously the 49 degrees is the same. So if we're looking at side, angle, side, we go check, and then we'll go, I don't know about the sides. Let's look. So what I want to know is if I compare 36, which is the larger one, to 25, which is the larger one here, is this equal to 35 compared with 24? Now, if this is a true proportion, then their cross products will be equal. That is to say, 36 times 24 would be equal to 25 times 35. And so we can look at that. 36 times 24 gives us 864, whereas 35 times 25 gives us 875. And so these are not similar. But if they had been similar, it would have been, we would have proven that by would have been SAS. There's no other way there to show that those are. Okay, so now, so wait, this is not a true proportion. And that's one way to show it. You could have also just divided 36 divided by 25. If you take 36 divide by 25, and that gives us a decimal 1.44. But if you take 35 divided by 24, you see that decimal is not the same. They're close, but they are not similar. So 1.44 is not equal to 1.458, etc., etc., etc. Okay, so now on this one, we have that this angle K is congruent to this angle S, because they show that with that single arc. That means those are congruent. I can say angle K is congruent to angle S. And this means that the measure of angle K and the measure of angle S are the same. So if let's say K was 60 degrees, then S would also be 60 degrees. If I said that K is 70 degrees, then S would also be 70 degrees. And that's what that arc means. So these are congruent. And then this angle right here, might call it angle LRK. Angle LRK is congruent to that angle TRS. They are called vertical angles. These two angles are congruent because they are formed by intersecting lines. They're opposite. Those then are always going to be congruent angles. So this angle for here and this angle here are congruent as well. And that's another way of showing congruence with this mark on the arc is another way of showing that congruency. So so this is yes. These are similar. By, let's see here quick. The angle similarity theorem. So it says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So it says here that these angles are that these sides are congruent. You can show that this angle and this angle, because they're alternate interior angles, those are congruent to each other, and this angle is congruent to this angle right here. Therefore, by angle, these two triangles are similar. And that's what we've shown here also. So these are similar by the angle theorem of similarity. Now, RST, notice we're starting at R and then we're going to S. So over here we're going to start at R, basically same angle, but this one instead of this one. And then we're going to go over here to the single arc, to K, R, K, and then the only one left then would be L, R, K, L. And there you have it. Ok. Ahora en español. Dice que hay que completar la declaración de similitud, semejanza, no estoy seguro. Esos dos triángulos son similares, y son similares significa de que los ángulos L y Q son congruentes porque ambos tienen estos dos arcos aquí. Esto también tiene los dos arcos, entonces esos son congruentes. Y eso se demuestra con esta declaración. Ángulo L es congruente con ángulo Q. Ángulo L es congruente con ángulo Q. Y lo hemos demostrado aquí en verde, aquí verde. Y ángulo R. El ángulo R, este, es congruente con ángulo M, que es este aquí. Entonces, por el teorema de ángulo, son congruentes, y se lo demuestra mostrando los mismos ángulos que son congruentes. Entonces han puesto primero L, hay que ir a Q. Entonces por eso pusimos Q al principio. Y luego han puesto M en el primero, y han puesto, entonces hay que poner R en el segundo. Y luego N, y de ahí N hay que poner S al final. Y el orden importa porque demuestra cuáles son los ángulos que son congruentes el uno con el otro. Ahora, en este ejemplo, está preguntando si son similares, y porque si son similares, entonces, ¿por qué teoremas son similares? En este he puesto que son similares por S a S, y S en inglés es side, angle, side. Yo supongo que en español sería L a L, lado, ángulo, lado. Entonces, si los dos lados son proporcionales, que están incluidos en el ángulo, que también son congruentes, serán similares entonces. Y aquí, en separar este triángulo chiquito, PEF o PFE, es este aquí. Entonces, separarlo del triángulo más grande, puedes ver que hemos comparado este 10 con este 10, y con este 45, que este 45, y este 10 que está aquí se compara con que es este, y se compara con 45 al otro lado, que es lo mismo. Obviamente 10 entre 45 en un lado es igual que 10 entre 45 en el otro lado, son del mismo valor. Entonces, por este side, angle side, S a S, L a L, lado, ángulo, lado, esos son congruentes, y la declaración de su similitud, de su semejanza, no estoy seguro cómo se dice, es triángulo PQR, el triángulo PQR, entonces es similar a PEF. El orden importa. Si tú dijeras, podría haber dicho este triángulo QPR, pero si lo haces así, empezando con QPR, entonces tendría que ser que es similar al triángulo EPF. EPF. Y el orden importa porque demuestra cuáles son los ángulos que son correspondientes y qué lados, qué ángulos son congruentes y qué lados son proporcionales con los otros lados. Ahora, en este siguiente, los dos ángulos, 45 obviamente sí son congruentes. 49 es igual a 49. Pero eso de 35 y 36 y 24 y 25, hay que ver si esos sí forman una proporción de verdad. Entonces he agarrado este 36 primero, arriba, y lo he comparado con el mayor de los dos lados aquí, 25. Entonces vamos a ver si comparamos los dos lados más grandes, si es igual que comparar los dos lados 35 entre 24, los dos lados más pequeños. Entonces, si es una proporción de verdad, los productos en X serán iguales. 36 por 24 será igual que 25 por 35. Entonces, cuando lo pusimos en la calculadora, puedes ver que no son iguales. Uno es 864 y el otro 875. También se puede comparar los dos lados, simplemente haciendo la división. Yo puedo decir, ok, esta razón, 35 entre 25, si hace la división, 36 entre 25 da 1.44, pero 35 entre 24 es 1.45, etcétera, etcétera, etcétera. Y eso no son iguales. Entonces, no, y por lo tanto, no son similares. Pero si fueran similares, habría sido por S a S, igual que el otro ejemplo. Y en eso sí son similares, y son similares porque los ángulos que son opuestos por el vértice, en inglés se llama vertical angles. Y esto es un ejemplo. Son ángulos opuestos y siempre son congruentes. Entonces esos dos ángulos son congruentes y te podré mostrar esos son congruentes. Entonces R es congruente, R congruente con R, S congruente con K, S congruente con K, y lo que queda, L será congruente con T, T con L. Entonces así es como se hace. Se pone la declaración de similitud poniendo junto a los que son congruentes. Obviamente R con R, S con K y T con L. Entonces en ese orden, así es como se hace. Bueno, suerte, si se puede, ustedes pueden. Sigue trabajando duro.